Hello everyone. Today we will discuss about the optical communication system. So we will go through the basic block diagram of the optical communication system and its function. So here you can see the basic block diagram of optical fiber communication system. Here you can see this is the information source from where the signal is generated or data is generated, and this is the destination. So in between information source and destination, there will be different blocks like electrical transmit, optical source, optical fiber cable, optical detector, and electrical receiver. In this electrical transmit, optical source, and optical fiber cable is a transmission cable through which the information is transmitted. And electrical transmit and optical source are the transmitter. It constitutes the transmitter, and this is the receiver end. So in transmitter end there is a optical source, and in the receiver there is a optical detector. So for optical fiber communication, optical source and optical detector is very important component. So first, the electrical signal. The information is in the form of electrical input signal, and that signal is converted to the corresponding optical signal by this optical source. And after this converted optical signal is launched into the optical fiber cable, and from here this optical signal reach up to the optical detector, and now optical detector will convert the optical signal into the corresponding electrical signal at the receiving end. So optical source and optical detectors are the two main components of any optical communication system, and in this series of video we will look the different types of optical sources, different types of optical detectors and their depth analysis. What are the impact, what are the different types, what are the data rates, all these parameters we are going to study in subsequent videos. So here in short, we are using two LED and the semiconductor laser as an optical source, and as an optical detector, we are using avalanche photodiode and pin diode. In subsequent video, we will discuss all these four in detail. Before that, we must know what are the basic characteristics of any light source that is used in the optical communication. So first characteristics is that the device or light optical source can work in different temperature range. Second, there must be high EO conversion. EO conversion means electrical to optical conversion. And through this we will get high optical output power. Next, the optical source can be modulated easily over a wide range of modulating frequency. This must be keep in mind before selecting the light source. Next, there must be large optical coupling, and we need to design the emitting area. We have to keep in mind that the emitting area must be small, and in order to reduce the material dispersion in an optical fiber link, the output spectrum must be low. What does it mean? It means when we are selecting any light source, we have to we have to keep in mind that that light source must have a small spectral width. Again, we have to keep in mind about the power requirement of the source and its reliability, its lifetime. So its required power is must be low. So we select our light source in such a way that it have long life and the power requirement is low. And the last thing is that the light source must be capable compatible with the modern solid state devices, mod, modern solid state devices like semiconductor and other electrical devices, electronic devices, and it must have high coupling efficiency. So these are the few basic characteristics that must be possessed by the any light source that we are going to use in the optical fiber communication. So next video what we will see, we will discuss about the different types of light emitting diode, and when we are using light emitting diode, when we are using laser diode, and we also discuss what are the different criteria on the basis of which we will select the LED or laser diode in our optical communication system. And after that, we will discuss about the optical detectors. Sources used in the transmitter and detectors used in the receiver section. Here you can see the experimental setup. This is the reference link. Here you can see this is the transmitter and this is the receiver. In the transmitter, there will be different electronic devices, optical sources for the conversion, then modulation. All these things are happening here at the transmitter end. And this is the optical cable through which the optical signals are transmitted and reach up to the receiver end. And in the receiver, there is a demodulator, there is a detector, there is a receiver, and optical to electrical conversion is happening at this receiver end. So in the laboratory session, you will do the experiment related to this. Thank you for watching this video, and in next video we will see about the LEDs.